Hello, in today's video we'll go over how to find the distance between 2 points and even the point directly in the middle called the midpoint. Let's get started. So to begin, I want to introduce where the distance formula comes from. The basic idea is if you were to plot 2 points on your xy coordinate plane, you could call the first point x1, y1, the second point x2, y2, like is defined in the box below here. And what we'd notice is that there's this interesting formula. D for distance equals the square root of parentheses x2 minus x1, so the distance in your x values, squared, plus parentheses y2 minus y1 in parentheses squared. Where in the world does that come from? Well, if you think about it, you could represent these 2 points, like we've done in the picture below, and then you could actually say, well, how can I get from point A to point B? Well, simply by drawing a line in between them. A straight line is always the shortest distance between any 2 locations, going straight. Well, another way of getting there, though, would have been to do a horizontal distance and a vertical distance. So, for example, we could have seen that there's a horizontal distance here. And how would we have gotten that horizontal distance? By subtracting the 2 horizontal values, right? Your first x location and your second x location, how far apart are they? The way we typically subtract values is the terminal minus the initial. So x2 being the second location minus x1 being the first location. That gives you the overall horizontal distance, which we typically would call the run when we think about slope. Similarly, if we wanted to figure out the vertical component of that distance there, we would say that y2 is our second y location minus y1 our first starting location. And that gives you your overall y or your vertical distance. We usually call that the rise when we think of slope. And so what we end up with is a right triangle, 90-degree angle in the corner. And what that would mean is that any sort of properties that right triangles possess would apply to this situation. So what is the famous property involving 3 sides of a right triangle that was discovered by a famous Greek man? That's right, the Pythagorean theorem. The Pythagorean theorem said that for any right triangle, where you have C being your hypotenuse, the side along the longest side, the longest side of the right triangle, which is across from the 90-degree angle. Then you have 2 other sides, you call them A or B, the legs of the right triangle. And the relationship that always holds was that A squared plus B squared equaled C squared. So because A squared plus B squared equaled C squared, then to get just C, we would take the square root. And that's what we've done here. C is the square root of A squared plus B squared. So then if you keep in mind that A was your horizontal distance, which is x2 minus x1, that was our A, and B was our vertical distance, y2 minus y1, then you see where this formula comes from. And it's another way of recreating the wheel, basically. So you don't actually have to just memorize a formula. You could understand where it comes from using the Pythagorean theorem for right triangles. So that's always a fair option. If you'd like to sketch the 2 points, draw the right triangle, and use the Pythagorean theorem to find that distance C, feel free. Otherwise, plug them into the formula. So here we have an example on this slide to the right here, where it says, could you find the distance between the points 1, 1 and 4, -2? So your choice is either to draw the picture and use the Pythagorean theorem, A, B, and C, and solve accordingly, or just to try the formula. So for example, if I wanted to just try the formula here, I would say that my distance should equal the square root of x2 minus x1. So my second x value minus my first x value. How far apart horizontally are they? Well, 4 minus 1 is 3. I'll write it out for those of you who like to see it. So that's our a squared, basically, x2 minus x1. Plus our y distance, y2 minus y1. What is our vertical distance between a y value of 1 and a y value of -2? Well, you could do a -2 minus 1. Just watch your signs there. How far apart is 1 from -2? Well, they're 3 units apart. In this case, -3 because of the order that we did things. Now, notice that the sign doesn't matter as far as -3 versus +3 because you're going to end up squaring those results. So in the end, we'd get the square root of 3 to the second power is 9. -3 to the second power is also 9. Notice it's not -9. So we get +9 because -3 times -3 is +9. And now look at where we're at. We now have the square root of 9 plus 9, or 18. And while that is a valid answer, we can always simplify radicals. We're expected to. So we think, well, 9 times 2 is 18, and the square root of 9 is 3. So in reality, this is 3 square root of 2, isn't it? So 3 square root of 2. Now this would be called the exact distance. As far as getting an approximate answer here, we would put it in our calculator as the square root of 18 or 3 square root of 2 and hit enter, and it'll give you a decimal answer. Now notice that for the square root of 18, that's bigger than the square root of 16, let's say. But it's also less than the square root of 25. The square root of 16 is 4, the square root of 25 is 5, so if you wanted an approximation, it's going to be 4 point something, and you could go into your calculator and get that approximation. And that should make sense because the horizontal distance was 3, the vertical distance was 3, that that longest distance, that C of the right triangle, should always be the longest distance. So 4 point something would make sense. So that would be like an approximate answer you could get. I've also attached the Desmos graph link in your notes. Feel free to check on that so you can visualize what's going on the graph. Okay, so let's have you apply the distance formula in the next example. Feel free to pause the video and try it yourself. It says find the distance between points P1, that's just the name of the point, and P2. And the way that they describe the distance between points P1 and point P2 is using the letter D for distance, and then in parentheses it has P1 comma P2, meaning the distance between point 1 and point 2. Where P1, point 1, has coordinates of -4, -3, and point 2 has coordinates of 6, 2. So feel free to use the graph provided in the notes to sketch it and visualize what's going on. Point 1 would be -4. Let me grab my pen here. 1, 2, 3, 4, and down 3. 1, 2, 3. There's point P1. On the other hand, so that was 3 units down, point P2, point 2, is 6 units right. 1, 2, 3, 4, 5, 6, but 2 units up. 1, 2, there he is. So the question is, how far apart are those 2 points? What is the distance between them? So we talked about one way of doing this is to just draw that line segment that connects them directly. That's what we're after. We want to find that distance. But in order to do so, we remember that we could simply make a right triangle. One right triangle would go this way, vertically to the left and then up. Sorry, vertically to the right and then up. So there's a right triangle. And how could we use the Pythagorean theorem? Well, we could simply count the units horizontally and the units vertically. So for example here, we went 4 left and we went 6 right. Well, that's a total of 10 units. That's like my A, isn't it? And here we went 2 units up and 3 units down. That's a total of 5, so that's like my B. So I could simply use the Pythagorean theorem. And in this case, the Pythagorean theorem would say that C squared equals A squared plus B squared, where A is 10, so 10 squared, and B is 5, so 5 squared, and that would give me my C squared. But 10 squared, it's not 20, but 10 times 10, which is 100, right? And 5 squared, it's not 10, but 5 times 5, which is 25. So we would have that C squared is 125. But that's not the distance C. That's way too big for C, right? We notice that C should be a little bigger than A and B. C should be a little bit bigger than 5 and 10. But 125 is way too big. And that's because we need to take the, that's right, square root of 125. And of course that can simplify, right? Because 25 times 3 is 125. Sorry, 25 times 5, I should say. 25 times 5 is 125. So we would have 5 square root of 5. Since we pulled out the 25 whose square root is 5. So this would be our exact answer. And the approximate answer, again, is a little bit bigger than the square root of 100, which is 10, and a little bit less than, also bigger than the square root of 121, which is 11. And so we would say, okay, it's trapped somewhere in between there, and we'd get our approximation that way, okay? In this case, though, I wanted to point out one other way you could have done this. So, or you could have used the distance formula directly. The distance formula said x2 minus x1 squared plus y2 minus y1 squared all under the square root. So what is our x2 minus x1? Well, that would be 6 minus a -4. So 6 minus a -4, keep in mind that's really saying 6 plus 4, which is 10. And then 10 squared is 100. So there's the square root of 100 part that we were looking for. What else? Well, then we would do y2 minus y1. Well, y2 is 2, so we'd have 2, and y1 is -3. So you'd have 2 minus a -3. Well, that's really 2 plus 3, which is 5, and we know that 5 squared is 25. And now we're getting right back to where we were here. We have the square root of 125, which simplifies to just 5 square root of 5. And then you can use your calculator to approximate if you'd like. Okay, so we practiced a couple of examples of finding the distance between 2 points. But let's say that instead of finding how far apart 2 locations are, we want to actually find the place that is exactly in the middle, equidistant, so equal distances from both of the other locations. For example, maybe you're at one location and your friend's at another, and you want to meet for lunch, right? Maybe one of you lives in Tampa, one of you lives in Orlando. Where should you meet for lunch? That would be finding the midpoint, the point directly in the middle. So let's go through intuitively how to do that and then talk about the formula on our next slide. So how do we find the midpoint of a line segment connecting 2 points? Well, it's really just going to be the average of each type of coordinate. What do I mean by that? Well, you have your x values. So if you have a point here and you have a point here, 2 points on your graph, well, they each have an x component and they each have a y component. So you want to find the middle x component and the middle y component. So think about how you normally find averages or middles. You add the units up and divide by 2 if you're just finding an average of 2 items. And that's what we see in our formula here. To find the new x location of your middle point in between the 2 points, we take the average of our x values, and then for the y values, we do the same thing. We add the y values and divide by 2. Notice we're not subtracting them, we're taking the average, which means add and divide by the total number. So for example, if our locations were the point 1, 1 and the point 4, negative 2, then to find the midpoint between them, we would take the average of our x values, so that would be our 1 plus our 4, and then divide by 2. That would give us our new x value. For the y values, we would take the average of them, which is 1 plus a negative 2, and then divide by 2. So let's see what that yields for us. 1 plus 4 is 5, so 5 halves would be the fraction, improper fraction for the answer. And 1 plus negative 2 is really negative 1. So negative 1 divided by 2 is really a negative half, because a negative divided by a positive is a negative number. That's why I put the negative in front. So as far as the middle location, that is the answer as far as fractions are concerned. If you prefer decimals, you could have said that's really 2.5 or 2.5 and negative 0.5. So either one of those mean the same thing. And now you have the location of your meeting place, the point right in the middle of those 2 points. And if you have a graph, it's always good to check that. You can click on the Desmos link to see that that's actually holding. And it works. All right, so at this point, you're going to try it yourself on the next example. Feel free to pause it and do it yourself. Here we go. It says find the midpoint between points P1 and P2, where P1 has the location of 2, negative 3, and P2 has the location of 4, 2. So again, if you want to visualize it, feel free to use the graph provided, or you could just jump right into the formula. So for point 1, we're at 2 to the right and 3 below. So that would be around there. And let me get a better color because you can't see that too well in that white here. Okay, so that would be 3 below and 2 to the right. There we go. For our second point, we go 4 to the right and 2 above. So that'd be right there. Okay, so if we were finding the distance formula, that would be a different formula, right? D equals the square root of x2 minus x1 squared plus y2 minus y1 squared, or the Pythagorean theorem. But we're actually asked to find the midpoint. So how do we do that again? To find the midpoint, we're really finding the new location for x and the new location for y. So how did we do that? Well, that's right. We took the average of our x's, x1 plus x2, and divide by 2. When you're learning formulas, it's usually helpful to write them out each time. For the y value, we take the average of our y values, so y1 plus y2 divided by 2. And now we simply plug in what we have here. Our first x value was a 2, and our second x value was a 4. So 2 plus 4 gets cut in half, or 6 gets cut in half, and we get 3. So the x value should be at 3. Let's see if that's making sense on the graph. 3 to the right would be around here. That does, in fact, look like it's the middle x value of 2 and 4. That makes perfect sense, doesn't it? Let's do the y value. The average of our y values would be negative 3 plus 2 cut in half, divided by 2. Well, negative 3 plus 2 is negative 1, and negative 1 divided by 2 would give me the negative fraction negative half. So let's take a look at where that would lead us to on the graph. We would have 3 to the right and then go down half a unit. Well, that definitely does look like a valid interpretation of a middle destination where we can meet for lunch, let's say, between our two France locations. Okay, so that is how we find the midpoint and the distance formula, all right? So we've practiced them together. Now it's up to you to practice them yourself, and I will see you next time. Good luck. Remember, math is not a spectator sport.